We are starting Chapter 3, which is all about angles and triangles. Today is 3.1, which is about parallel lines and transversals. So let's start by defining parallel lines. And parallel lines are lines in the same plane In other words, we could say they are lines on the same graph or the same area that do not intersect. So lines that do not intersect. Then we have perpendicular lines. And perpendicular lines are kind of the opposite of parallel lines. Perpendicular lines are lines that intersect at right angles. So a picture of this, if I had two lines that go like that. They do not touch, they will not ever touch, and these are parallel. And we can mark that they are parallel by putting little arrows on them. And that shows one arrow is parallel to one arrow. Then we can have perpendicular lines. And these intersect at a right angle. This little square shows that it is a right angle, and these are perpendicular. So we talked about parallel lines. Now let's talk about transversals. And a transversal is a line that intersects two or more lines. So I could have a transversal that goes through those two lines. And in here, when parallel lines are cut by a transversal, several pairs of congruent angles are formed. Part of these congruent angles would be corresponding angles. And corresponding angles are angles that are in the same spot in reference to the transversal. So they look like they're in the same spot. In reference to the transversal. So let's look at what this could be. So I'm going to have parallel lines here. And I'm going to mark their parallel with my little arrows. and they're going to be cut by a transversal. So I'll make a little note. These are parallel, and this is a transversal. Then I have corresponding angles. So let's look at this angle here. That corresponds to this one. They're in the same spot, the upper left and the upper left. I could have this one here. They're in the upper right part. I have the lower left. And I'm putting different numbers of lines here so that you can see, oh, 3 lines is the same as 3 lines. Those angles are going to be the same. And then I have this last one, and I'm going to put 4 little lines here to show that this is the same. So, the colors show which ones correspond, but it also shows that these are going to be congruent. If they are parallel and they are cut by a transversal, the angles that are created are the same. So, corresponding angles are congruent. So pink is congruent to pink, greens are the same, blue is the same, orange is the same. So this angle is congruent, meaning they have the same measure. They are exactly the same as this one here. Pink and pink, green and green, blue and blue, orange and orange. So we can do some things with this. If we have, we're going to find the measure of angle 1 and angle 2. So to show I'm talking about angles, I put a little angle symbol. This is not a less than symbol. It kind of looks like it, but it's not quite. So if I have 2 parallel lines here, and they are cut by a transversal, I am going to say this one is 120 degrees. This is angle 1, and this is angle 2. So I know, because of corresponding angles, my 120 degrees corresponds to angle 1. (120 degrees is a corresponding angle to angle 1. We know corresponding angles are congruent, so therefore angle 1 is congruent. This is the symbol for congruent. To 120 degrees. Or we could say angle 1 is 120 degrees. Now to find angle 2, we have to know something called a supplementary angle. And supplementary angles are angles that add up to 180 degrees. So we know that if angle 1 is 120, angle 1 plus angle 2 must equal 180. So angle 1 plus angle 2 is 180. Angle 1 is 120. So 120 plus something is 180. So angle 2 is 60 degrees. So then I found the measure of angle 2 and the measure of angle 1. Make a note here. Angles 1 and 2 are supplementary. They are supplementary. Now, while we're talking about supplementary angles, it's important to mention that we have complementary angles. And complementary angles are angles that add to 90 degrees. Supplementary, 180, complementary, 90. So knowing all of this, let's look at another example. Again, we are going to find angle measures. So find the missing angle measures. I'm going to have a couple parallel lines. Cut by a transversal. And your transversal can go any way through your parallel lines. Could be a right angle, could point up to the right like this, could point down to the left. And we have some angles in here. So we have angles 1, 2, 3, 4. Five, 6, 7, 8. And let's say all we know is that angle 3 is 75 degrees. Can I find the rest of these? I can. So let's start by identifying what we started with, which are corresponding angles. So I'm going to start with the one that I know. 3 corresponds to 6. I'm going to make a little list here so that I can keep track of what I know. Corresponding angles, 3 and 6. I can have 3 corresponds to 6, 4 corresponds to 7, 2 corresponds to 5, and 1 corresponds to 8. So I know those. So if angle 3 is 75 degrees, and it corresponds to angle 1, we know angle 1 and 3 are congruent. Corresponding angles are congruent. So we know angle 3 is congruent to angle, I wrote a 6. Angle 3 congruent to angle 6. We know these are congruent. And so angle 3 is 75. So angle 6 is 75 degrees. Now I know that 3 and 4 are supplementary. So supplementary with angle 3 is angle 4 and angle 2. So this means angle 3 plus angle 4 equals 180 degrees. Angle 3 is 75 degrees. We don't know angle 4, but it still equals 180. To solve for angle 4, subtract 75, and angle 4 equals 105 degrees. So, I have a couple pieces now. I know the measure of angle 6, I know the measure of angle 4, I know the measure of angle 3. That was given. Now, if angle 2 is also supplementary, I could rewrite this with angle 2. And then I will have angle 3 plus angle 2 equals 180. And then we'll get to angle 2 also equals 105 degrees. If I follow the same process as angle 4, angle 2 is 105. I know angle 6, let's see. Angles 3 and 6 are corresponding. 4 and 7 are corresponding. So because I know 4 now, I also know 7. I also know 2, so now I know 5. Okay, so this means angle 7, angle 4 equals 105, and angle 4 is congruent to angle 7, so angle 7 equals 105 degrees. I know angle 2, and angle 2 corresponds to angle 5. So angle 2 is congruent to angle 5. Angle 2 is 105. So angle 5 is 105. So now I only need to find angle 1 and angle 8. So let's look back. I know angle 2, I know angle 4, and I know angle 3. Angle 1 is supplementary with angle 2. It's also supplementary to angle 4. So these will form supplementary angles. So I know angle 2 plus angle 1 equals 180. Angle 2, we just said, was 105. So I can do 105 plus angle 1 equals 180. Solving for angle 1, angle 1 is 75 degrees. And because angle 1 corresponds to angle 8, angle 1 is now congruent to angle 8. Angle 1 we said was 75 degrees, so angle 8 also is 75 degrees. Now I know all of my angles. Let's look. I know all my angles. I have angle 1, angle 2, 3, 4, 5, 6, 7, and 8. So, if I'm looking up here at angles 6 and 8, angles 6 and 8, they're kind of opposite each other in this X. Let's look at what can we figure out from angles 6 and 8. Angle 6 is 75, and angle 8 is 75. So we have a name for what it's called when angles are opposite each other in an X, and that is called vertical angles. And vertical angles, we said, angles where their vertexes touch. A vertex is the corner. So the little corner in your angle. They are opposite sides in an X. And since angle 6 and angle 8 are vertical angles, and they have the same measure, we know that vertical angles are congruent. So, just starting out with one angle, I was able to find all the other angles. And now we have a few tools that we can use when finding angle measures.